Hello, this is the projectile motion experiment setup, and we have a ramp here, and the shape of the ramp is made so that at the bottom it's horizontal. So when the ball fire at this position, it only has horizontal speed. And this photo gate is connected with the Logger Pro, the Verna software. It helps us to record the time when the ball passes by the photo gate. And then the projectile motion starts here. The ball will be fired horizontally and it will land on floor, and we will measure the distance on the floor. First, I use this plumb to locate the initial point on the floor, so I'm going to make a mark over there. So I predict the ball will land around here, so I put a cover paper on top there. Okay. So next I'm going to start collect the data. So to start, so this is the program to help us to measure the gate time, the time when the ball passes by the photo gate. I click collect. And next I'm going to start here. Release the ball at this position. Okay, so this is the data, the gate time we're going to record. This is the gate time, delta t. We use this one to find the initial speed. And for the range, and when the ball hit the carbon paper, there is a dot there. Okay, so the range is basically the distance it traveled horizontally. So we use the meter stick to measure the distance from the initial point to this one. So for example, for this trial, the distance is at about the other way. So that's about 61 centimeter. So we're going to do 6 trials, and every time the ball start at the same height. So I just show you how to collect data. I will attach a data table later. Okay, how to analyze the data. So okay, so this is the data table you can find on Blackboard, and you do 6 trials, and every trial you record the gate time delta t, and record the measured range. That's the horizontal distance of floor. You try measure that's the measured range. And so our results table, we will find the predicted range. So you can theoretically predict the range. So basically, this range is the distance the ball traveled horizontally. So horizontally, no acceleration. That's motion with constant velocity. So to predict to find the range, we have to find the initial speed and the time. And the initial speed, we use the photo gate to find the initial speed. And when the ball passes through the photo gate, and the software record the time it travel, the time it block the signal here. So that's timing. And then we want to find what's the distance the ball traveled during that short time interval. So you see, when it starts block the signal, that's the initial moment, and after it passes, it stops recording. So the distance it traveled for this time interval is actually the diameter of this ball. And so you measure the diameter, and the distance, the initial speed is going to be distance over time, and diameter divided by the gate time, the delta t. Once you find the initial speed, you can come back to this equation to find the predicted range. But to calculate that range, you also need this time. This is different from the gate time. This is the time the ball is in the air during the projectile motion. So after it leaves the photo gate until it hit the ground. And so you need this time. To find the time, you will analyze the motion in vertical direction. So vertical direction, we can measure the height, and we know the free fall acceleration, g equal to 9.8 meter per second square. So you can solve time from the vertical direction motion and plug in that t back here to find the predicted range. Okay, so this is the data, and this is the results table. So the predicted range, the average of this column, and the measured range, the average of this column. And I want you to do a standard deviation calculation and a standard deviation of the mean. So in the data analysis, do show the sample calculation. So for horizontal speed, for predicted range, standard deviation, and standard deviation of the mean. And for the sample calculation, always include the original equation and the data. So the standard deviation in the same method that you did for the free fall motion. So this is the equation to calculate the standard deviation, and so standard deviation of the mean will be the standard deviation divided by square root n. N is the number of trials. So today's lab we did 6 trials, so there will be n will be equal to 6. And you can also use your calculator to find the standard deviation. And this is the procedure how to use your calculator to find the standard deviation. But in your notebook sample calculation, do show one sample calculation for the standard deviation and standard deviation of the mean.